Hello, honorable judges and respected audience. My name is Anna Marie Andrade. I'm 8th grade from Our Lady of the Assumption School. My phenomenon project is, how were ancient viruses able to survive for centuries in Arctic glaciers?
The polar region. The polar region includes both the north and south poles. They stay cold all year, with temperatures often below freezing. But due to climate change, ice in these areas is melting faster than ever, which is why scientists are so concerned about what might be released from the ice. What's lurking beneath the ice? Deep in the Arctic and Antarctica, glaciers seem lifeless, but they actually preserve ancient ecosystems. Among the most surprising things found, ancient viruses frozen in ice or permafrost for tens of thousands of years, and now beginning to re-emerge as climate warms. The Arctic and ancient viruses. Let's define a few key terms. Permafrost is ground frozen for at least 2 years. Glacier ice is dense ice that forms over centuries. Ancient viruses are prehistoric microbes preserved in this frozen environment. The image on the right shows how snow compresses into dense layers, possibly trapping viruses. The image on the left shows how frozen ground layers can protect viruses for thousands of years. Prehistoric pathogens. In Siberia, scientists discovered an ancient virus like Pithovirus sibricum, revived after 30,000 years. They proved that viruses can survive extreme cold for thousands of years and still be active. How they survive. How did these viruses last so long? Cold stops decay and slows down chemical reactions. Ice and soil block light and oxygen, protecting the DNA. Their genetic material stays intact, basically paused in time. Virus preservation in glaciers. Here's the process. A virus enters the environment. It gets trapped in ice or frozen in soil. The freezing stops it from doing. When the ice melts, it becomes active again. In 2016, melting permafrost in Siberia led to an anthrax outbreak from a thawed reindeer. This shows how melting glaciers could release viruses that pose new health risks.
Why we should care? We should care because melting glaciers could release ancient viruses. This poses health risk and adds effects of climate change. Studying these viruses could also help us improve freezing technology. This image shows us emission versus temperature projection, highlights risk of reactivating ancient viruses and climate.
What we can learn. Studying ancient viruses helps us improve cryopreservation for vaccines, understand virus evolution, monitor melting areas to protect public health. So, how did ancient viruses survive? Extreme cold, isolation, and time. As glaciers melt, we face real risk, but also chances to learn, prepare, and innovate. Here are my resources I used to be able to construct this presentation. Thank you for listening. I hope you now see the science and mystery behind the ice.